All right, guys. Question 7. Again, another question was skipped, but because it was something that I did not do with my students. So anyway, I will do the rest of the questions when I have the time. But we're going to look at this question 7, a 5 marks question. This is definitely strictly a binomial distribution question. So again, no surprises. Part A, it says that state one criterion in addition to independence that would support them using a binomial distribution to find the probability for their prediction. Okay, I mean, there are many possible answers for this. Some of you might say that we know that in a binomial distribution you need to have a number of fixed trials, which would be in this case the 5 children. We also have to consider the probability for every child needs to be 0.75. Okay, so again, there is lots of choices for you to write in terms of the binomial distribution condition. So I think we could say that I would probably use the probability. Okay, so I could say that in part A, the probability of brown eyes, which is like a success, because you need success or failure, is always P equal to 0.75 for every child. Okay, which means that the chance of a child having brown eyes does not change across all 5 children. Okay, that's what it really means as well. Of course, you could say there are many possible answers. You could say that each child eye color is independent of the others as well. That is fine, because the eye color of one child does not influence the eye color of the other. Okay, so that's really what independence is all about, right? So but since the independence have been mentioned, then you could talk about maybe the fixed number of trials. So the number of trials, which is like your children, is fixed at n equal to 5. That is fine as well. What it really means is that since Maria and Alex has like 5 children, so the sample size is kind of predetermined in this case. Again, pick your choice, but I like to use the probability because I think that's like the most logical one for binomial distribution. Okay, so B part 1. All right, exactly 3 of the 5 children will have brown eyes. Again, if you're using the Inspire, this is a great calculator to use. TI-84, I absolutely hate it when to use the TI-84 when it comes to binomial distribution, because it doesn't allow you to form the lower and the upper bounds as well. Okay, if there is a software update somewhere that does it, please let me know. I'm not aware of it at this point of time, but it is still a struggle for students, especially in B part 2, which I'll talk about shortly. So if I'm looking at exactly 3 of the 5 children that has brown eyes, so before we do that, okay, I always say let X be the number of children with brown eyes. Okay, so this is good to write it. You want to define this, okay, because this question technically, all right, even though it says earlier that it's a binomial distribution, but I think it's a good habit to do this. So be X binomial distribution will be 5 trials. This will be 0.75. Okay, and sometimes in other questions where binomial distribution is not mentioned, this actually gives you marks, because it tells the examiner that you know that this is indeed an application of the binomial distribution. Okay, so B part 1, I'm looking at when X is equal to 3. Now again, when you put this onto the calculator, since we're looking at a specific value for X, in this case we're going to use the binompdf. Okay, what I want to do is I'm going to put all these values onto the calculator. Okay, I just want to show this, like this is not technically a proper way to demonstrate or show as part of your workings, but you get the point, because this is actually what you're going to be putting onto your GDC. Okay, so binompdf, let's do that. So we're going to go to second vars. I'm going to choose binompdf. Okay, So it asks for n, p, and x value, so it's 5. Where's my comma? Then the p would be 0.75. Then I'll put a comma, then I'll put a 3, press enter. Oh, why am I on the graph? This is annoying. So wait, let me try this again. Yeah, okay. Let's try this second vase. Not even sure why I was on the graph. Binomcdf. Okay, so it's 5, comma, 0.75, comma, and 3. Press enter. Okay, 0.264. There we go. That's the answer. That's the one I'm looking for. 0.264. Okay. 0.75. Let me just double check. 0.75 and 3. Yeah, that's correct. Okay, now B part 2. What I'm looking for is x at least 4 of the 4 children. So I'm looking at x greater or equal to 4. Now, technically, there are 2 ways to go about doing this. Alright, now, it's particularly if you're using the TI-84, you have to decide for yourself which one is a quicker way for you to get the answer. Now, x greater or equal to 4, because since we got 5 children, one way is you could find what is the probability when x is 4 and when x is 5, because there's only 5 children that we have in this question. So you could actually do binompdf twice for these two, get the 2 answers, add them up. That's one way to do it. Or what you could also do is I could take 1 minus probability of x less than or equal to 3. Now, because since we're looking at the probability of 4 and 5, then we need to look. The thing is, why we do this is because the TI-84 doesn't allow you to do a binomcdf of 4 and 5. So anything that's bigger or equal to a specific number, the TI-84 doesn't work very well with this, okay? Because it only works with the less than or equal to that number. Now, since we're looking at 4 and 5, then it makes sense to find what's the probability from 0 to 3. And if we get the probability, we subtract from 1. That's going to give you like the rest of the probabilities, which is 4 and 5, because we only have 5 children in this case. So this one, this is where you can do a binomcdf. Then I'll do a 5, 0.75, and I'll put a 3 here. Okay, then you could just work it out, the answer, and subtract that from 1. Okay, so let's really quickly put this onto the calculator. So 1 minus second vase, binompdf, CDF. Then I'm going to do 5, comma, 0.75, comma, 3. And you're going to get 0.633. There we go. 3SF. Okay, 5 marks in the bag. So, if this was done with the Inspire, easy. You can put the boundaries in, which is 4 and 5, and you're done, and you should get the same answer as well. Okay, so anyway, hopefully this video helps. This is actually all for paper 1, because the rest of the questions are not something that I have taught my students at this point of time. So I'm going to move on to paper 2 in my next video. It's going to be a really long one. The next few questions can be quite a long question, so that's where I really don't like paper 2. I think paper 1, generally, the ones that I kind of expect, I think generally they're fine, but the ones that I did not cover in paper 1, there's quite a fair bit of calculus questions as well, which I really don't think the kids or the students generally would like paper 1. I think paper 1 generally has some of these hard questions, but paper 2 is extremely long, extremely lengthy. Anyway, we'll cover that in the next video. Alright, so guys, as always, please support the channel, like my video, subscribe as always. See you soon.